Hello students, welcome to this lecture, one pair of linear equation in two variables. So in this lecture, we will discuss ncert exemplars, one pair of linear equations in two variables. So let's get started. So here we have question number 1. So in this question, here we have to graphically solve the pair of linear equation 6x minus 3y plus 10 is equal to 0 and 2x minus y plus 9 is equal to 0. Okay, so the pair of linear equation, this and this represents two lines which are what? So here we have given four options. So among these four options, which option will correct, that we'll have to find here. Okay, so first of all, we have to draw the graph of this pair of linear equations, and then we have to see where it is intersecting, or it is parallel to each other, or coincide to each other. Okay, so let us see how to solve it. So we can write equation 1, 6x minus 3y plus 10 is equal to 0 as 2x minus y plus 10 by 3 is equal to 0. Basically here we divide this equation by 3 and we get 2x minus y plus 10 by 3 is equal to 0. Okay, and second equation, 2x minus y plus 9 is equal to 0. And from this equation, so this is our first equation and this is our second equation. Okay, and now from this equation, from equation 1, here now we have to make table. So for 2x minus y plus 10 by 3 is equal to 0, here when if we take x is equal to 0, then you will get the value of y is equal to 10 by 3. Okay, and when x is minus 5 by 3, then the y is equal to 0. Okay, and now table for 2x minus y plus 9 is equal to 0. Okay, so if we now make the table for this equation, then when you take x is equal to 0, then you will get the value of y is equal to 9. And when you take x is equal to minus 9 by 2, then you will get the corresponding value of y is equal to 0. Okay, so now if we plot these points one a graph, then I will get this type of diagram. Okay, so you will get this type of graph. So this represented the equation 2x minus y plus 9 is equal to 0. Okay, so 2x minus y plus 9 is equal to 0 is represented by this line, and here this line, here 2x minus y plus 10 by 3 is equal to 0, this equation is represented by this line. Okay, so here you can see at point C and D, this line intersects y-axis and x-axis respectively. Okay, and here for this equation, so this equation, the graph of this equation, here this graph intersects the x-axis at 0 comma 10.3 and y-axis at point minus 5 by 3 comma 0. Okay, so hence here these two linear equation, pair of linear equations represent two parallel lines. Okay, so they are parallel to each other. So therefore these two pair of linear this pair of linear equation, so 6x minus 3y plus 10 is equal to 0 and 2x minus y plus 9 is equal to 0, this pair of linear equation represents two lines which are parallel. Okay, so which are parallel. So here option number D is correct answer. So correct answer is option number D, that is this pair of linear equation, this pair of equations are basically parallel to each other. And now let us move to question number 2. Okay, so in next question, here we have the pair of equation x plus 2y plus 5 is equal to 0 and minus 3x minus 6y plus 1 is equal to 0, and it said to us the pair of equation has which type of solution. Okay, so in option A we have a unique solution, in option B we have exactly two solutions, and in option C we have infinitely many solutions, and in option D we have no solutions. Okay, so we have studied in our previous lecture where we have studied pair of linear equations. Okay, and we can now compare this pair of linear equation with the general form of pair of linear equation, that is a1x plus b1y plus c1 is equal to 0 and a2x plus b2y plus c2 is equal to 0. Okay, so if we compare with this with that general form, then you will get the value of a1 b1 c1 and a2 b2 and c2. Okay, so let us see here the solution. So here given equation are x plus 2y plus 5 is equal to 0 and minus 3x minus 6y plus 1 is equal to 0. Okay, so here if we compare this equation with the general form of pair of linear equation, a1x plus b1y plus c1 is equal to 0 and a2x plus b2y plus c2 is equal to 0. Okay, then you will get the value of a1 is equal to 1, the value of b1 is equal to 2, c1 is equal to 5, and a2 is equal to minus 3, b2 is equal to minus 6, and c2 is equal to 1. Okay, so now if we find the ratios, so here you will get a1 by b1, this is equal to a1 by b1, this is equal to 1 by a1 by a2, this is equal to minus 1 by 3, b1 by b2, this is equal to 2 by minus 6, that is equal to minus 1 by 3. Okay, and the ratio c1 by c2, this is equal to 5 by 1. So here you can observe that a1 by a2, this is equal to b1 by b2, but does not equal to c1 by c2. Okay, so here this condition hold, a1 by a2, this is equal to b1 by b2, but does not equal to c1 by c2. And we have studied in our previous lecture, if this condition hold, a1 by a2 is equal to b1 by b2 but does not equal to c1 by c2, then the pair of linear equation has no solution. Okay, that case the pair of linear equations basically are parallel to each other. That is why the pair of linear equations has no solution. Okay, so hence the pair of equation has no solution. So here in option D we have no solution. So the pair of equation x plus 2y plus 5 is equal to 0 and minus 3x minus 6y plus 1 is equal to 0 has no solution. Okay, so here option number D is correct answer. Okay, so the correct answer is option number D. And now let us move to question number 3. So in question number 3 here we have if a pair of linear equation is consistent. So when a pair of linear equation is called consistent, so you know when a pair of linear equations has a solution, at least one solution, then the pair of linear equation is called consistent pair of linear equation. Okay, so here it is given to us if a pair of linear equation is consistent, then lines will be what? So here we have given 4 options. In option A we have given parallel, the lines will be parallel. In option B we have always coincident. In option C we have intersecting or coincident, and in option D we have always intersecting. Okay, so we know when the lines will be parallel, that case the pair of linear equation has no solution. Okay, so that case the pair of linear equation is inconsistent pair of linear equations. But here we have given if a pair of linear equation is consistent, that means the pair of linear equations has at least one solution. Okay, so option A is not possible. So here let us see the question. So solution. So here condition for a consistent pair of linear equations basically are a1 by b1. This is not equal to b1 by b2 when the lines will be intersecting line having unique solution. Okay, and when a1 by a2 this is equal to b1 by b2, this is equal to c1 by c2, then coincident but dependent. Okay, so here if a pair of linear equation is consistent, then the lines will be intersecting or coincident. That means when the lines will be intersecting, that case we will get the solution of a pair of linear equation is unique. Okay, and if the lines will be coincident, that case you will get the solution of a pair of linear equation is infinitely many. Okay, so the in this two case here we get at least one solution. Okay, so that is why if a pair of linear equation is consistent, then the lines will be intersecting or coincident. Okay, so it is not always coincident, it is not always intersecting, and it is not parallel. So here option number C is actually right answer. Okay, so here option number C is correct. This is our correct answer. Okay, so now let us move to question number 4. So in question number 4, here we have the pair of equation y equal to 0 and y equal to -7. Okay, and here we have given 4 options. In option A, we have one solution. In option B, we have 2 solutions. In option C, we have infinitely many solutions. And in option D, we have no solution. Okay, no solution. No solution. So the pair of equation y equal to 0 and y equal to -7. So let us solve which type of solution will have this pair of linear equations. So here the given pair of equations are y equal to 0 and y equal to -7. Okay, so you can draw the graph of this pair of linear equation. Okay, so the y equal to 0, this equation actually represented by this line y equal to 0, that is actually x axis. Okay, so y equal to 0 is this is represented by the x axis, and y equal to -7, y equal to -7, y equal to -7, this is actually the line which is parallel to x axis. Okay, so this line is represented by the y equal to -7, this is represented by this line. So here you can see the y equal to 0, this line, and y equal to -7, this line, they are actually parallel to each other. Okay, so by graphically both lines are parallel and having no solution. So here for this question, option number D is correct answer. So this is our correct answer, no solution. So option number D is here correct answer. And now let us move to question number 5. So in question number 5, here we have pair of equation x equal to a and y equal to b, and here we have to graphically represent the lines. Okay, so the pair of equation x equal to a and y equal to b, first of all we have to draw the graph of this pair of linear equation. Okay, so let us see how to solve it. So by graphically, in every condition, if a b, this is positive, both are positive, or a b both are negative, or a positive b negative, or a negative b positive, but a equal to b does not equal to 0. Okay, so that case the pair of equation x equal to a and y equal to b graphically represents lines which are intersecting at point a comma b. If a comma b greater than 0, that case you can represent by this graph. Okay, so this is our x-axis, this is our y-axis, and the point a comma b is here. So here this line, the y equal to b represented by this line, and x equal to a, this is actually parallel to the line parallel to y-axis and represented by this line. Okay, so x equal to a and y equal to b, these two equations intersect at each other at point a comma b. Okay, so here x equal to a and y equal to b graphically represents lines which are intersecting at point a comma b. Okay, and if a comma b greater than 0. So similarly, in all cases, two lines intersect at point ab. Okay, so here option number D is correct answer. So for this problem, here the pair of equation x equal to a and y equal to b graphically represents lines which are intersecting at point at a comma b. That is, here the correct answer is option number D. Okay, so the correct answer is here option number D. And now let us move to question number 6. So in question number 6, here we have for what value of k do the equations 3x minus y plus 8 is equal to 0 and 6x minus ky is equal to -16 represent coincident lines. Okay, so we have given pair of linear equations, and here we have to basically find the value of k. So let us see how to solve it. So here you can solve this by using this approach. So condition for coincident line is basically A1 by A2 is equal to B1 by B2 is equal to C1 by C2. Okay, so basically here A1, B1, C1, A2, B2, C2 are the coefficients of the general form of the pair of linear equations A1x plus B1y plus C1 is equal to 0 and A2x plus B2y plus C2 is equal to 0. Okay, so the condition for coincident lines is basically A1 by A2 is equal to B1 by B2 is equal to C1 by C2. And here we have given lines 3x minus y plus 8 is equal to 0 and 6x minus ky plus 16 is equal to 0. Okay, so this is given to us. So here from equation 1, from this equation here from this equation, if we compare now these two equations, then we will get the value of A1 is equal to 3, B1 is equal to minus 1 and C1 is equal to 8, and A2 is equal to 6, B2 is equal to minus k and C2 is equal to 16. So now if we find the ratios A1 by A2, B1 by B2 and C1 by C2, then we will get A1 by A2 is equal to 3 by 6, B1 by B2 is equal to minus 1 by minus k and C1 by C2 is equal to 8 by 16. Okay, so we know for the condition for the coincident line A1 by A2 is equal to B1 by B2 is equal to C1 by C2. Okay, so 3 by 6, this is equal to minus 1 by minus k and this is equal to 8 by 16. And if we take now first two ratio, then we will get 1 by k is equal to 1 by 2 and it implies k is equal to 2. Okay, so the value of k is equal to 2. So here you can now match the option. So here in option C we have the value of 2. So the value of k is equal to 2 for that this pair of linear equation represent coincident lines. Okay, so now let us move to question number 7. So in question number 7, here if the lines given by 3x plus 2ky is equal to 2 and 2x plus 5y is equal to 1 are parallel, then we have to find the value of k is what. Okay, so let us solve this problem. So here we have basically given these two lines. Okay, and for these lines are parallel, we have this condition A1 by A2 this is equal to B1 by B2 but this does not equal to C1 by C2. Okay, so here given lines are 3x plus 2ky minus 2 is equal to 0 and 2x plus 5y minus 1 is equal to 0. Okay, and now if we compare this pair of linear equation with the general form of pair of linear equations A1x plus B1y plus C1 is equal to 0 and A2x plus B2y plus C2 is equal to 0, then here A1 is 3, B1 is equal to 2k and C1 is equal to minus 2. Okay, and here A2 is equal to 2 and B2 is equal to 5 and C2 is equal to minus 1. And now from equation number 1, now from this equation here 3 by 2 this is equal to 2k by 5 and it implies k is equal to 15 by 4. Okay, so the value of k is equal to 15 by 4 and here in option C we have 15 by 4 this value. So here for this question, the line given by 3x plus 2ky is equal to 2 and 2x plus 5y is equal to 1 are parallel, then the value of k is equal to 15 by 4. Okay, so the value of k is equal to 15 by 4. So here the correct answer is option number C. So option number C is here correct answer. And now let us move to question number 8. Okay, so in question number 8 here we have to find the value of C, for which the pair of equation cx minus y is equal to 2 and 6x minus 2y is equal to 3 will have infinitely many solutions. Okay, so which for what value of C this pair of linear equation will have infinitely many solutions. Okay, so let us solve it. So if you see the solution here, condition for infinitely many solutions, that is actually A1 by A2 this is equal to B1 by B2 is equal to C1 by C2. Okay, and here the given lines are cx minus y is equal to 2 and 6x minus 2y is equal to 3. So the given lines are 6x minus y is equal to 2 and 6x minus 2y is equal to 3. So here A1 is equal to C, B1 is equal to minus 1 and C1 is equal to minus 2. Okay, and A2 is equal to 6, B2 is equal to minus 2 and C2 is equal to minus 3. Okay, now this from this equation a1 by a2 is equal to b1 by b2 is equal to c1 by c2. Here we get c by 6 is equal to minus 1 by minus 2, and this is equal to minus 2 by minus 3. Okay, so here c by 6 is equal to 1 by 2. Also, if we take first two ratio, then you'll get c by 6 is equal to 1 by 2, and it implies c is equal to 3. And if you take second two ratio, then you'll get first and third ratio, then you'll get c by 6 is equal to 2 by 3, and it implies c is equal to 2 times 6 by 3, that is equal to c is equal to 4. Okay, since c has different values, okay, so here we get one value of c is equal to 3 and other value of c is equal to 4. So here we have basically two different values of c. Okay, since c has different values, so hence for no value of c, the pair of equation will have infinitely many solutions. Okay, so there is no value of c that for which the pair of linear equation cx minus y is equal to 2 and 6x minus 2y is equal to 3 will have infinitely many solutions. So here option number D is correct answer. Okay, so the value of c, so no value of c for which the pair of equations cx minus y is equal to 2 and 6x minus 2y is equal to 3 will have infinitely many solutions. Okay, and now let us move to next question. So this is our question number 9. So it said to us one equation of a pair of dependent linear equation is minus 5x plus 7y minus 2 is equal to 0. Okay, so we basically have to find the second equation can be what. So basically here one equation of a pair of dependent linear equations. So pair of dependent linear equations means they're actually parallel to they're actually coincident to each other. Okay, so we know condition for dependent linear equation, that is a1 by a2, this is equal to b1 by b2, and this is equal to c1 by c2. Okay, so given equation of line is minus 5x plus 7y minus 2 is equal to 0. Okay, so this is our given linear equation, and basically we have to find another equation where this equation actually contain one pair of dependent linear equations. Okay, so here here a1 is equal to minus 5, a2 b1 is equal to 7, and c1 is equal to minus 2. Okay, and now from this equation number 1, here minus 5 by a2 is equal to 7 by b2, this is equal to minus 2 by c2, and this is equal to 1 by k. So a2 is equal to minus 5k, b2 is equal to 7k, and c2 is equal to minus 2k. So now from equation number 1, here k is any arbitrary constant. Okay, so here basically if we put the value of k is equal to 2, then we get a2 is equal to minus 10, b2 is equal to 14, and c2 is equal to minus 4. So therefore the required equation of line becomes a2x plus b2y plus c2 is equal to 0, and that is minus 10x plus 14y minus 4 is equal to 0. And if we now rearrange this equation, then you'll get 10x minus 14y plus 4 is equal to 0. Okay, so this is our required equation. So this equation and given equation, they are actually a pair of dependent linear equation. Okay, so one equation of a pair of dependent linear equation is minus 5x plus 7y minus 2 is equal to 0. Then the second equation can be 10x minus 14y plus 4 is equal to 0. Okay, so here correct answer is option number D. Okay, so option number D is here correct answer. So I hope this is clear to you. Now we can move to another question. So now let us move to next question. So in next question here we have a pair of linear equations which has a unique solution x equal to 2 and y equal to minus 3. Okay, so we have given this pair of linear equation x equal to 2 and y equal to minus 3, and here we have given this pair of linear equation has a unique solution. Okay, so here which option is correct, that we'll have to find here. So now let us see how to solve it. Okay, so let us see how to solve it. So here if x equal to 2 and y equal to minus 3 is a unique solution of any pair of equation. So basically this is our unique solution among these the pair of equation which is actually in among these four options. Okay, so here you can check by substituting the value of x equal to 2 and y equal to -3 in this equation, which equation is satisfied by this x equal to 2 and y equal to -3, then that equation will be pair of linear equations. Okay, so if x equal to 2 and y equal to -3 is a unique solution of any pair of equation, then these values must satisfy that pair of equations. Okay, so from option number B, here if we substitute the value of x equal to 2 and y equal to -3, then in left hand side we'll get 2x plus 5y, that is equal to 2 times 2 plus 5 times -3, that is equal to 4 minus 15, and this is equal to -11. So -11. So here x equal to 2 and y equal to -3 satisfied this equation, and now we can check this equation also. So here if we substitute the value of x equal to 2 and y equal to -3 in left hand side of this equation, then we get 4x plus 10y is equal to 4 times 2 plus 10 times -3, and this is equal to 8 minus 30, that is equal to -22, and this is actually equal to right hand side of this equation. Okay, so this equation here this value x equal to 2 and y equal to -3 satisfied this equations. So the pair of linear equation which has a unique solution x equal to 2 and y equal to -3 is 2x plus 5y is equal to -11 and 4x plus 10y is equal to -22. Okay, so here option number D is here correct, and option number B is here correct answer. So correct answer is option number B. Okay, so now let us move to question number 13, and so let us move to question number 13. So here the father age is 6 times his son's age. 4 years hence, the age of the father will 4 times his son's age. The present ages in year of the son and the father are respectively what? So here we have given 4 options. In option A we have 4 and 24. In option B we have 5 and 30. And in option C we have 6 and 36. And in option D we have 3 and 24. Okay, so let us see how to solve it. Okay, students, so let us see how can we approach it. So first we can let x here be the present age of father and y here be the present age of his son. Okay, so for year hence it has relation by given condition x plus 4, this is equal to 4 times y plus 4. Okay, and if we simplify this, then you will get this equation x minus 4y, this is equal to 12. Okay, so x minus 4y, this is equal to 12, and now here for father's age is 6 times his son's age. So from this information we'll get this equation x is equal to 6 times y. Okay, so basically here we get two pair of two linear equations. One is x minus 4y is equal to 12 and another is x equal to 6y. So this is a pair of linear equation. So now we can solve this pair of linear equation by using algebraic method like elimination method, substitution method. Okay, so here basically one putting the value of x is equal to 6y in equation number this, we get 2y is equal to 12 and it implies y is equal to 6. Okay, and when y is equal to 6, then if we when y is equal to 6, then x is equal to 6 times 6, that is equal to 36. Okay, so hence present age of father is 36 year and age of son is 6 year. So here in option C, here we have this information. So here correct answer is option number C, 6 and 36. So the father age is 36 and the son's age is 6 years. Okay, so I stop here this lecture. So student, thank you very much to all of you.